Gen AI and tools like ChatGPT didn't just appear out of nowhere. They've been part of a long, evolving journey. While the data and theories underpinning AI have roots that go back decades, if not centuries, the real acceleration has occurred only in the last few years. AI development initially moved at what felt like a snail's pace, but recent advancements have propelled it forward at a remarkable speed. Our journey starts in the 1950s with Alan Turing, a brilliant mathematician who not only helped shorten World War II by breaking the Enigma code, a feat credited with saving millions of lives, but also introduced the concept of machine intelligence. This was the first step towards what we now call artificial intelligence. In 1964, MIT's ELIZA became the first chatbot capable of simulating a basic conversation. It was a significant milestone, offering a glimpse into how machines might one day understand and respond to human language. The 1980s marked a pivotal moment when IBM's chess-playing computer defeated Garry Kasparov, the world chess champion. This wasn't just about winning a game. It showcased AI's ability to use machine learning to make decisions based on probability, a concept we'll explore further as it's foundational to modern AI. In the early 2000s, we saw the emergence of generative adversarial networks, GANs, which can create new data from existing data. This led to the phenomenon of deep fakes, realistic but entirely fabricated images and videos. If you haven't already, I recommend looking up deepfakes online. The results are as fascinating as they are unsettling. Then, in 2011, Apple introduced Siri, making AI-powered voice assistants a part of everyday life. This was a significant leap in bringing AI into our homes and hands. Finally, in November 2022, OpenAI released ChatGPT 3.5, which dramatically altered the AI landscape. Within just 5 days, it reached 1 million users, demonstrating how AI had finally gained mainstream traction after decades of slow, steady progress. And with major companies like Google entering the field, the pace of AI innovation has only continued to accelerate. As we move forward, we'll explore how these developments have shaped the AI tools we use today, particularly in how we interact with them through prompting. Of AI, let's get a clear understanding of what AI actually is. At its core, AI, or artificial intelligence, refers to computer systems, or machines, capable of performing tasks that typically require human intelligence. Let's think about this a bit. Machines doing tasks that require human mind. These tasks often involve problem-solving, pattern recognition, and language understanding. Things that, until recently, we thought only humans could do. For example, think about planning, analyzing data, adjusting to new information, or continuously learning from experience. These are all functions that human brains are exceptionally good at, and now we're teaching machines to do the same. It's not just about automation, but about creating systems that can handle complex tasks, make decisions, and even understand human language. As we go further into this course, you'll see how these capabilities are being applied in everyday life and why understanding AI is becoming so crucial. As we dive deeper into the world of AI, it's important to understand what we're truly dealing with when we compare AI to the human brain. The human brain is an incredibly complex and powerful organ, and it's what AI aspires to replicate or even surpass in certain tasks. But to appreciate the challenge that AI faces, let's take a closer look at the remarkable capabilities of the human brain. Storage capacity. The human brain contains approximately 86 billion neurons, each capable of making thousands of connections. This gives us what is essentially unlimited storage capacity. Imagine trying to build a machine that can store and process that much information. This is one of the immense challenges AI researchers face. Neural connections. These billions of neurons form a network of quadrillions of connections. This complex network is what allows us to think, learn, and adapt with incredible speed and flexibility. AI systems, like neural networks, are designed to mimic these connections. But the sheer scale and complexity of the human brain's network is still far beyond what current AI systems can achieve. Information speed. Information in the human brain travels at speeds up to 250 miles per hour, which is faster than a Formula One car. This incredible speed allows us to react almost instantaneously to stimuli, process complex information, and make decisions in the blink of an eye. AI, on the other hand, often requires significant computational power and time to process similar tasks. When we talk about AI matching or surpassing human cognitive tasks, it's important to remember just how advanced our own brains are. The human brain's ability to store vast amounts of information, make complex connections, and process data at lightning speed sets a high bar for AI. While AI can excel in specific tasks, replicating the full range of human cognitive abilities is a challenge that researchers are still working to overcome. Now that we've defined AI and what we are up against when it comes to human brain, let's explore the key types of AI that are currently recognized in the field. AI can be categorized into three main types: narrow AI, general AI, and super AI. First, we have narrow AI, which is the most common form of AI in use today. Narrow AI, also known as weak AI, is designed to perform a specific task or a set of related tasks. It's called narrow because it operates under a limited or narrow range of conditions. Examples of narrow AI include virtual assistants like Siri or Alexa and recommendation systems used by platforms like Netflix or Amazon. These systems are highly effective within their specific domains but cannot operate outside of them. Next, we move to general AI, which is also known as strong AI or human-level AI. General AI refers to a hypothetical type of AI that possesses the ability to perform any intellectual task that a human being can do. This means it would have the capacity to understand, learn, and apply knowledge across a broad range of tasks, much like a human. While general AI is a goal for many researchers, we're still far from achieving it. Finally, there's super AI, which goes beyond even general AI. Super AI is theoretical and represents an intelligence that surpasses human intelligence across all domains. It would be capable of not only performing tasks that humans can do, but doing them better and faster, with greater accuracy. Super AI remains purely speculative at this point, and there's considerable debate over whether it will ever be possible or desirable. Currently, we are at the stage of narrow AI, but we are gradually progressing towards general AI. Understanding these types helps us grasp where we are today with AI and where we might be headed in the future. For now, most of the AI we interact with daily is narrow AI, but the concepts of general and super AI guide much of the ongoing research and discussion in the field. Now take a look at the core components that are critical for AI to function effectively. The ability for AI to learn, see, process, and plan is at the heart of what makes AI powerful and versatile. These core components can be broken down into several key areas. Machine learning. This is the foundation of AI, enabling systems to learn from data, identify patterns, and make decisions with minimal human intervention. It's how AI systems improve over time as they are exposed to more data. Natural language processing, NLP. NLP is what allows AI to understand and generate human language. This is crucial for applications like chatbots, voice assistants, and translation services, where understanding the nuances of language is key. Computer vision. Just like humans use their eyes to see and process visual information, AI uses computer vision to interpret and analyze visual data. This includes everything from recognizing objects in images to navigating through environments. Knowledge representation. This is about how AI systems store, organize, and access information. It's essential for reasoning, decision-making, and drawing conclusions from the data they have. Reasoning. Reasoning enables AI to make logical decisions based on the knowledge it has. It's critical for problem-solving and planning, allowing AI to choose the best course of action in a given situation. Planning. AI uses planning to set goals and figure out how to achieve them. This involves breaking down tasks, predicting outcomes, and adjusting strategies as needed. Robotics. Robotics combines many of these AI components to create machines that can perform physical tasks. Whether it's assembling products on a factory floor or navigating through complex environments, robotics brings AI into the physical world. These components work together to create AI systems that can think, learn, adapt, and even interact with the world in a human-like way. As we move forward in the course, we'll delve deeper into each of these areas to see how they contribute to the overall functionality of AI. Now that we've covered the core components of AI, it's time to put what you've learned into practice with an interactive demo. On this slide, you'll see a link that says, "Click here," or on the image for an interactive demo. When you click on it, you'll be taken to a dashboard where you can explore different scenarios and determine whether the machine in each scenario qualifies as AI or not. When you click this link, you will be taken to one of the popular large language model, LLM tools called Claude. You may be asked to create an account. Please do, it's free, and will allow you to fully experience the interactive demo. This demo is designed to reinforce the concepts we've discussed by giving you hands-on experience. As you go through the scenarios, the dashboard will explain why a particular machine is or isn't considered AI based on the characteristics we've just learned about. Take your time with this demo and don't hesitate to explore the explanations provided. It's a great way to solidify your understanding of AI and see how these concepts apply in real-world examples. Once you're done, we'll regroup and discuss any questions or insights you might have. Now that we've covered the basics of AI and its core components, let's take a look at how AI is integrated into our everyday lives through smart machines. These applications are all around us, often in ways we might not even realize, making our daily tasks easier and more efficient. Let me start with something close to home for me. In my experience working at a credit card company, we leveraged AI in a critical way. Before any transaction is approved, we would run it through close to 10 to 15 different algorithms. These algorithms were designed to detect fraudulent activities by analyzing transaction patterns in real time. This AI-driven approach not only protected consumers from fraud, but also safeguarded the financial institutions. It was a game changer in ensuring security and trust in financial transactions. Similarly, when I was involved with a marketing company, the power of AI was evident in how we approached SEO. Most of our search engine optimization efforts were driven by AI algorithms that could analyze vast amounts of data to ensure our content was always relevant and ranking highly on search engines. At GE, where I later worked, AI played a pivotal role in managing our operations and driving efficiency. We used AI to optimize our processes, streamline operations, and ultimately improve our bottom line. The ability to predict maintenance needs or optimize supply chains made AI an invaluable tool. More recently, in the healthcare sector, the impact of AI has been nothing short of revolutionary. We use AI to predict close to 100 different medical conditions, estimate how long a person might stay in the hospital, determine the best treatment plans, recommend actions to healthcare providers, and solve complex member issues. The use cases are endless, and as we continue to innovate, AI will only become more integral to improving healthcare outcomes. Now, turning back to the broader world, fraud detection. AI is a cornerstone in financial systems, detecting fraudulent activities by analyzing patterns in transaction data. This ensures the protection of both consumers and financial institutions. Tesla, self-driving cars. Autonomous vehicles like Tesla's self-driving cars rely on AI to navigate roads, recognize obstacles, and make real-time decisions. This is among the most advanced AI applications we encounter in daily life, edging us closer to a future where driving might be fully automated. SMS, word recommendation. Ever notice your phone suggesting words or correcting your spelling as you type? That's AI. It analyzes your typing habits and language patterns to predict and recommend the next word or correct errors, making communication smoother and more intuitive. Google Search. Every time you use Google, AI is working behind the scenes to analyze your query, understand its context, and deliver the most relevant results. This makes Google Search so powerful and efficient, processing billions of queries daily. Social media recommendations. On platforms like YouTube, Facebook, or Twitter, AI is constantly at work analyzing your behavior to recommend content it predicts you'll enjoy. These recommendation systems are designed to keep you engaged by tailoring your social media feeds to your interests. Drug discovery. In the pharmaceutical industry, AI is accelerating the process of discovering new drugs. By analyzing large datasets, AI can identify potential drug candidates much faster than traditional methods, leading to quicker development of life-saving medications. These are just a few examples of how AI and smart machines are already deeply embedded in our daily lives. From the experiences I've shared, it's clear that AI is not just a distant, futuristic concept. It's here, actively transforming industries and solving complex problems. As we continue to advance, we can expect AI to play an even more significant role, enhancing everything from how we work to how we interact with the world around us. Before we wrap up part 1, let's take a moment to reflect on what we've discussed so far. The complexity of the human brain and the rapid advancements in AI raise some important questions. Do you believe AI can truly replicate or surpass human intelligence across all domains? Think about the areas where AI excels and where it still falls short compared to human cognition. What are the most significant potential benefits and risks of continued AI development? Consider the positive impacts AI can have, but also the challenges or dangers that might come with it. As AI becomes more integrated into our daily lives and work, it's crucial to think about its broader implications. How do you think AI will reshape industries, job markets, and the skills valued in the workforce? Reflect on how AI might change the landscape of work and what new opportunities or challenges it might create. What ethical considerations should guide the development and deployment of AI technologies? Ethics is a critical part of AI development. Consider the responsibility that comes with creating systems that could impact society in profound ways. Take a few moments to think about these questions. Please send your response to Discord channel or my email in the class notes where we can discuss them together to see where everyone stands and to hear different perspectives. This reflection will help prepare you for the quiz that follows, where you'll get a chance to test your understanding of the key concepts we've covered.